So this is the code which is in VS Code. Let's talk about the main files of this project. So the first main file, basically the entry point of this project is, let me just open this. I have some documentation created by the AI. So the main entry point of this object is the index file. So if I go to index file, it basically uses commando.js package to basically consume the commands which we run from the terminal, and then it basically sends it to the parser to convert them into a form which can be used by the client package. So if we go to index.ts, this is the main entry point, and it is built using commander.js. Let me open that index.ts. So this, if you see this index.ts, it has code for all sorts of command that we run from the terminal. So if you see, it has create session. So this creates the session. It uses commander .js program to create a session with the MCP server, and that will be long running session with the help of some other module that we have in the project. So you can see all the commands which we can see on the CLI, that is present here. Like if I use this command, it will start the session. Basically this is the main executable that will be used to make any command, and this is the like first prefix of any command. So if I want to connect with the servers, I need to run MCP CLI sudo connect and the server URL. If I want to do help command, I need to do MCP CLI help sudo.help. So let me if I want to show these commands to you, let me just open the terminal. So if I go here, it's if I need to show that how this command.js commands done using this index.js. If I do, let's say help, so you can say when I run the help, it is showing me all possible commands that we can run on this CLI on this CLI package. So it has connect. Connect is used to connect with the MCP servers. Close is used to close a session which is existing with a MCP server. You can restart a MCP server session if you want to restart a session with some MCP server. Then you have login. Login is to, if any MCP server has login authentication in it, then you can use login command to basically do auth authentication with the server, and that login information will be stored in the session using keychain to make a persistent connection, so that you don't have to log in again. You can log out from the MCP server. If you have a long running session in the CLI, you can clean the CLI using clean command, and there are a few other commands as well. Also we have uh, so these are the core, these are the commands which are related to my CLI itself. But how about the commands that I'll use to execute some operation on the server? So those commands are listed here. You can to list tools of the MCP servers, you can use this tools list. To get a tool information or a schema, you can use this tools call. Then to call a tool with certain parameters, you can use tools call. So I'll execute all of these one by one, and I'll show in practical how it works. To get the prompts list, to get the resources, so all these commands you can use. And so there are you can see there are two parts of each of the command. One is the command of my CLI, and second is the command that that is used to operate on the MCP server. So yeah, I think so you can see all these commands just by seeing running the help command. And you can see here, as I was saying, that index is the main entry point. So it is binding all the commands here. You can see when help you run, it will display all the information related to help. You can use verbose to see the logging and all that. So index is basically entry point, and it is binding all the commands using commander.js. And for each of the commands, it has one program here. So you can see, like for restart, it has for tools, there's one program for tools list. And yeah, so it is registering all the commands, you can see. So it's registering all the commands in the session, help, close, restart. All these are useful commands of the CLI and being registered. That's why I call it the entry point of the of my CLI client. Then let's go to this and I have used a coding tool called Client to basically code it. I have given the design, but I have not, I mean, to make the things faster. Obviously, nobody's coding hand by hand these days, so I've used Client to code it. So you can see like index.ts I have explained. So second is parser.ts. So parser.ts job is as I was talking in architecture itself. Uh, if I go on the architecture. Let me open that image which I had, right? Components architecture. So parser is the file that does this parsing operation, which is part of the MCP CLI component. So I will explain that file how it works. So if you see this parser file, what it does. So the parser job is to take the inputs from the CLI using stdio pipeline, and then it will parses that command to convert into a form that can be used by the client package. So if you see here, it passes what it passes the tool arguments, it passes the tool name out of your command. Or if you are sending any let's say natural language query in your input, because when you call a tool, you are not going to you're not going to specify exactly how it going to be on the MCP server. So you specify in certain format, that format is taken by this parser, and then it parses the tool names, tool arguments out of it, and converts into a JSON RPC 2.0 protocol payload, and that payload is used by the MCP client.ts, this file, to call the MCP servers, because MCP servers needs JSON RPC payload, and to prepare that payload you need to parse certain thing out of the command that we are putting in the CLI terminal. So it is parsing the tool name and tool arguments here, and then it prepares the input for the MCP tool call. So yeah, for each of the command it has different parser. So it is checking, does the command has sub command, so it parses the sub command. Means let's say you're saying that uh, MCP server name, that connect, and then certain arguments. So arguments are the sub commands, right? So all these things are done in the parser.ts. And then the next thing I want to highlight is, let's say if you see the main files, it has output.ts is used to format the output in a human readable form. So if something coming from the MCP server, this output.ts converts it into a human readable form and JSON and provides it to the user. Then we have then comes to the CLI layer. So on the CLI layer we have certain things. So on the CLI we put certain commands, and those commands needs to be mapped with either tool or query, tool or prompt or resources, because there are three entities in MCP server. So the commands also should be mapped to one of these three entities. So for those three entities, we have three files in the commands folder. First is tools folder. So tools folder uh, maps the commands to each of the uh, main operation that we do on the MCP server. It can be call tool, or it can be, let's say, list tool. If I say list tool, so list tools it can be. So it basically takes the input and pass and takes the command and then maps it to one of the operations of the server. Then same for the resources. Resources also are one of the entities on MCP server. So it can be list resources or list resource template, or get resource. So all those operations are mapped with the command which we are running on the terminal using this file. Then for the same for the prompt, getting the prompt or listing the prompt, all those things are done by this prompts file. And then when these commands are mapped using these files, then it goes to the next layer, which is our MCP client.ts. So MCP client.ts is one of the main files, and this is the actual file that prepares the JSON RPC payload, and it directly talks to the MCP server. So all other files which I mentioned, those supply the data to this file, and this file is actually the one which is preparing the payload to talk to the MCP server. To do so, it also needs MCP client class, and that MCP client class is created by transport file. So transport file creates, as I mentioned in the architecture overview, it can create two kinds of clients. One is stdio transport, or second one is the streamable HTTP. So stdio is for the MCP servers which are running locally, and streamable HTTP is for MCP servers which are running remotely. So this transport file functions are used by the factory class to create these client instances, and the factory class stores those client instances in the factory object, and those instances are used by the MCP client file to make connections and execute operations on the actual MCP server. So it's using this dot client, and this client is basically, it's a pool of client that is maintained by the factory class. And why do we need factory class? Because we don't want to make connection for each of the query. When the query comes, it should not reconnect, because that will create latency. So it already maintains a pool of connection object that can be easily picked and reused on the query time. So that is the use of factory class. And yeah, I may explain most of the important things. The last thing in this is the bridge. So bridge, what the bridge does is, CLI commands are mostly short-lived, as we know, right? So because if you run any CLI command, and since we are building a CLI client, whenever we run any command here, right, let's that will be a short-lived command. But what we need here is a persistent connection between the CLI and the MCP server. You know, connection should not drop, because MCP server is a stateful protocol, and stateful protocol, what they need is, they need a persistent connection between client and server. So to maintain that persistent connection, we use something called bridge. And bridge, what it does is, it makes this connection persistent between the CLI and the MCP server using persistent sessions, and making the ping calls to MCP server every 30 seconds. So if I go into the bridge file, you see that it's pinging the MCP servers which are connected during initiation every 30 seconds. If you can see, it's start periodic keep alive. So what it does, it is keep the connection alive with the MCP server throughout the session using periodic pings which are happening at certain intervals. So here it is doing that thing, right? Along with that, this also, maintains the persistent connection, and this is very useful. And how it takes the input from the CLI, that it does using stdio IPC stdio input output. So whenever you run any command, let's say you run help command, so this input goes through uh, std in, and that std in will be used by this bridge package. So this bridge package, what it does, it uses that data to supply it to the MCP server, and make the connection alive using the ping operation. And then whenever the server responds back, it gives it back to the CLI using std output. So std input, std output is used to bridge the connection between CLI and MCP server, and that's why it's called bridge. So if you want to see what package is used for bridge, so you can say, like, I think there is no we are not using any custom package. This bridge is a logical design that you can build by basically having a persistent ping to the server, and also having std input output layers to take the input from the CLI, and also supply the output to the CLI using std output. So you can see it has all sorts of things. It has handle connection socket server. So it's maintaining a persistent a live connection throughout the session with the MCP server. Okay, so yeah, that's about the code part. Now let's see the practical things. Let's see, like, how we can start this, how we can talk to the MCP server, and how we can do some operations.